Alright, so for this video, we are going to discuss with another type of differentiation for another type of function. Alright, so we are going to talk about the differentiation of inverse trigo function. Okay, so inverse trigo function, you only learn one type of inverse trigo only, which is we want to differentiate the tangent inverse x. So when you want to differentiate tangent inverse x, generally you're having 1 over x squared plus 1. So you just bring the x down here, become the x squared, and then plus 1. So this is a pattern. All right. In general, if let's say you're having tangent inverse u, then what will happen is you put it as 1 over u squared plus 1. Okay, so 1 over u squared plus 1, and after that, you need to differentiate the u, and you multiply it with your answer. So this is differentiate with u, differentiate the u to get over dx. All right. So this is the general equation that you should know. Okay, so this is actually one of the new syllabus that only introduced in year 2020. So if let's say you try other partial question, you will see this kind of question appear in the partial question before year 2020. All right. So they introduced this in year 2020 is because of they actually want to link it with another function later when we want to do the integration. So it makes the process of integration easier. All right, so please make sure that you try to remember this. Only tangent inverse, sine inverse, and cos inverse will not be included. All right, okay, so let's have a look for all the example here. So example 7. Okay, so they want you to differentiate each of the following with respect to x. Okay, so first equation is you're having y equals to tangent inverse 6x. Okay, so when you want to get the dy dx, what do you have? So again, the pattern will be 1 over x squared plus 1. So your x now is 6x, or maybe the u, okay, is 6x. And then you have to differentiate the 6x, you have the, then if you rewrite again, you are having 6 over 36x squared plus 1. So this will be your answer. Okay, so I don't think that it is hard. So maybe you can try the other example first. Pause the video, try the other example, and then you double check with the answer. Okay, so what is the answer for the second part? So they want you to differentiate tangent inverse 2x over 3. So again, when you want to have dy dx, you will have 1 over 2x over 3 and then square, then plus 1. After that, you multiply with the differentiation of 2x over 3. So you're having 2 over 3 here. All right, so maybe you can put the 2 over 3 in front first. Then when you try to simplify it, you have 4x squared over 9 plus 1. Okay, so when you have 4x squared over 9 plus 1, this whole equation, right, looks very weird. So we will try to make the denominator with fraction disappear. So to make the 9 disappear here, you multiply this whole bracket with 9. And also on top, you have to multiply it with 9. So multiply it with 9, multiply it with 9. Okay, so if you try to simplify it, 3 and 9 can be cancelled off with each other. So you're having 3 times 2, which is a 6. And then when you try to factorize or maybe try to simplify this one, you have 4x squared plus 9. Okay, so this is how we simplify it. So do you get the answer correctly or not? Okay, and then now we go to part number C. All right, so again, as what I told you before, right? Generally, for all the types of functions that you learn how to differentiate, they will actually try to combine it already. Okay, so let's have a look for part C here. They want you to do the differentiation for tangent inverse e power x. So there are 2 types of function here. One is tangent inverse, another one is exponential. So the main function is actually tangent inverse, it is outside. So the main function is tangent inverse, okay? So to do the differentiation for this, tangent inverse, you're having 1 over x squared plus 1. After that, you multiply the differentiation of e to x. So when you multiply the differentiation of e to x, what do you have here? Okay, so do you still remember how to differentiate e power 2x? So you copy the original thing, then you differentiate the power again to get a 2 Okay, so when you try to rephrase everything, you should have e 2e2x divided by e power 4x squared, then plus 1. Sorry, it is not e power 4x squared, it is e power 4x only. Because the power multiplied with power, 2x multiplied with 2, you get a 4. So it should be e power 4x plus 1. Okay, so this is how we do it. You need to combine two differentiation of the function together, but the main function is tangent inverse. After that, only you differentiate the thing inside the tangent inverse here. Okay? All right, then after that, we go for part number D. All right, so what is the answer for part D? Okay, so you're having y equals to e tangent inverse x. So now the main function is e. Okay, so the main function now is e. How can you do the differentiation for this? So when you want to do the differentiation for e power tangent inverse x, you copy back the original thing, and after that you multiply it with the differentiation of the power. So when you differentiate tangent inverse x, you have 1 over x squared plus 1. Okay, so usually your answer will look something like this, divided by x squared plus 1. Okay, so I hope that you get the answer correctly, because I think all these are quite basic, just to test you on the process of the differentiation for tangent inverse. All right, okay, so this is what we have here. Then let us continue. Okay, so again, like other questions, they will also ask you to do the differentiation for the application. All right, so now let us have a look. Find the equation of tangent to the curve at this curve, all right, when x equals to 2. Okay, so first of all, you need to do the differentiation first, because they want you to find the equation of tangent, right? So you need to find the gradient of tangent. So to find the gradient of tangent, you need to do the differentiation. Okay, so what is dy dx? All right, so dy over dx, it is equals to 1 over x over 2 squared plus 1. And then you do the differentiation of the half x. So when you do the differentiation with half x, you're having half. Okay, then I put in front first. When I try to simplify this, right, okay, I'm having x squared over 4 plus 1. Okay, then I multiply the whole thing with 4. Okay, on top, you multiply with 4. At the bottom, you also multiply with 4, so that the denominator, okay, the fraction at the denominator disappear. So 2 and 4 can be simplified. You're having 2 and over x squared plus 4. So this is how your answer look like for the dy dx. Okay, so some students will say, if let's say they ask for the differentiation, they ask for the equation of tangent, can I just leave my answer like this? No need to simplify it until this stage. Also can. It is not wrong, because they will just look at the, they will just look at the method, the way that you differentiate it. If let's say the process is correct, then it's okay. You don't need to rephrase it into this pattern. But if let's say the question requests you to rephrase it into a certain pattern, they have to follow. But for this example, they didn't ask you to do so, so you can keep your answer like this, no problem at all. Okay, all right, then after that, this is your dy dx. So I want to know the gradient of tangent. Okay, so how to get the gradient of tangent? So the gradient of tangent is dy dx, and you need to substitute the value x equals to 2 in your dy dx. And therefore, you're having 2 divided by 2 squared plus 4. You're having 2 over 8. And therefore, your gradient of tangent is 1 over 4. And then, when x equals to 2, you need to find out the y. So what is the y here? So tangent inverse 2 over 2 means tangent inverse 1. So tangent inverse 1, you have 45 degrees, which is pi over 4. Okay, so I want you to take note on this part here. The value of y, you must write it in the radian form. You cannot write it in 45 degrees. The answer will be wrong. Okay, because for all the differentiation, integration that involve all the trigo, answer of x and y must be in terms of radian or in the unit of radian. So you cannot write in 45 degree. It would be definitely wrong. Okay, so please take note on this part. Right, so 45 degree means pi over 4. Lah. So you have the gradient now, you have the passing point, x equals to 2 and also y equals to pi over 4. Then you can start to form the equation. Okay, so what's the equation of tangent? Alright, so the equation of tangent will be y minus y1 equals to m x minus x1. So you try to simplify your equation and write in a proper way. Okay, so you're having half here, so you can write y equals to 1 over 4x minus half plus pi over 4. Okay, so this is the equation of tangent that I get. Alright, so again, you'll see that the process of finding out the equation of tangent is still the same like what you learned before. So that's why I didn't go through in very detail with you how to get the gradient of tangent and everything. So all the process you must know it yourself because you already learned it last semester. Alright. Okay, so just that they now apply the equation of tangent in the differentiation of inverse trigo. So make sure that you know how to do the differentiation for tangent inverse. Alright, okay, so next one. Okay, so let's have a look for example 9. They give you an equation here and they want you to show that d square y dx square equals to this answer. Okay, so no matter how, we will start from the original equation first. So you're having y equals to x minus tangent inverse x. Okay, so for this equation, if I try to do the differentiation, I will have 1 minus 1 over x squared plus 1. Okay? And after that, they actually want you to prove that if you continue to differentiate it for another time, this is the answer that you should get. Okay, so maybe now you have to think how can you get this step, all right, to get the answer that they want you to show. Okay, so how should you do that? So maybe before I continue to differentiate for another time, I will rewrite my equation again. So it will become 1 minus x squared plus 1 power negative 1. Agree or not? Okay. So now, if I look at this equation here, they are having d squared y dx squared. That means you need to continue to do the differentiation for another time. Okay, so from here, you continue to differentiate for another time. 1, differentiate 1, you will get a 0. Okay, so for this one, it's a bracket with power. So to differentiate it, you need to bring the power in front. So you become negative 1. You copy back the bracket, power minus 1 become negative 2. And after that, you need to do the differentiation inside this bracket. So when you differentiate 2x, x squared plus 1, you'll get 2x. Okay, so try to rephrase it. You have something like 2x divided by x squared plus 1 squared. Okay, so now from here, your answer of d squared y dx squared is this one. But now the problem is they actually want to rephrase it like that. How can you rephrase it? Okay, so you try to compare the answer given in the question and also your answer here. You realize that, okay, 2x, I'm having 2x. So you pull the 2x in front. Okay, and then for after you put the 2x in front, now you're having 1 over x squared plus 1 squared. So it can rewrite it become 1 over x squared plus 1, and then the whole thing squared outside. So compare this pattern again. You are one step closer to the answer that they want you to show. Okay, how can I prove that 1 over x squared plus 1 is 1 minus dy dx? Okay, so you actually get the value from here, get the equation from here. Okay, so you can see that 1 over x squared plus 1, when you move it over, it will become 1 minus dy dx. So you substitute it into this part, and eventually you'll get the answer. D square y over dx squared is equals to 2x, and then 1 minus dy dx squared. So this is the pattern that they want us to show. Alright, the original d squared y dx squared will look something like this. So you have to try to compare your answer with the answer that they require, and then you slowly rephrase your answer into what they want. Okay, so I hope that you have the idea how to do the differentiation for tangent inverse. Mainly all the example here, they want you to understand, okay, or they want you to know how to do the differentiation for tangent inverse. Alright, okay, so this is what we have. Okay, then for next part onwards, we are going to continue with the product rule and quotient rule. Alright, so I discuss this in the next video then.